All right, today, guys, we're going to take a look at the sensitivity and specificity activity. And so this is going to focus in on the results that come back when we administer any medical test. So let's look at our intro here. When a medical test is evaluated as to how good it is, two different measures are calculated for any medical test that is given to patients. The first is what is called the sensitivity of the test. And so the sensitivity measures how well the test identifies those patients who have the disease. Sensitivity is the probability that the test result is positive when we know that the person has the disease. So if we're talking about the sensitivity of a test, what we are saying is how good a job are we doing at catching people who actually have the disease. So if they have cancer, when they are given the medical test, they actually test positive for cancer. As opposed to sensitivity, we also have the specificity of a test. The specificity measures how well the test identifies those patients who do not have the disease. Specificity is the probability that the test result is negative when we know that the person does not have the disease. So here we're testing how well we tell healthy people that they are healthy. So if they come in and they don't have cancer and we run a test for cancer, the specificity is telling us what percentage of people we're telling they don't have cancer when indeed they don't. So at first you might think that when a test is administered that there are only two outcomes because the patient either has the disease or does not have the disease. But there are actually four because our test isn't always accurate 100% of the time. And so we actually have four possible outcomes. The first of those possible outcomes is that the patient has the disease and the test accurately identifies the patient with a positive test result. Because if the test result comes back positive, that means they tested positive for the disease. Outcome number two is the patient has the disease and the test incorrectly identifies the patient with a negative test result. So even though they have the disease, the test is telling them they're okay, they're in the clear, they don't have the disease. Outcome number three, the patient does not have the disease and the test correctly identifies the patient with a negative test result. So because they don't have the disease, the negative test result means they don't have it. That's a correct decision. And in number four, we have the patient does not have the disease, but the test incorrectly identifies the patient with a positive test result. So even though they don't have the disease, the test makes a mistake. It comes back and it says you have whatever disease was being tested for. So let's take a look at this example. We start by knowing that there are 100 people, and we know going in that 90 of these people are healthy and 10 of them have cancer. We give them all this same medical test for cancer. We apply it to all 100 people. 9 of the cancer patients accurately receive positive test results. So if we look at where is this going to go in the table, these 9 people, they had cancer and they accurately received a positive result. That was a correct decision. And so cancer and positive result, we're going to put a 9 there. Next up, we have one cancer patient who inaccurately received a negative result. So this was a cancer patient, received a negative result. We've got one person that fell into that box. Then we have 80 healthy people that accurately received negative test results. So there were 80 healthy people who got a negative result. That was the correct decision because they did not have cancer. Then there were 10 healthy people who inaccurately received positive results. So these 10 people, they're healthy. They do not have cancer, but when the test comes back, they were told that they have cancer. So now that we have the results of this test, we know where everyone falls, we can take a look at, well, what was the sensitivity of this test and what was the specificity? So remember, sensitivity measures how well the test identifies those patients who have the disease. So we are going to take a look at, well, how many people had the disease? That's 10 people here actually had cancer. And out of these 10 people, how many times did we catch that they had cancer? Well, 9 of them had results come back saying they had cancer. So 9 out of 10 times we caught that they had cancer. That means then 9 divided by 10 gives us 0.90, which as a percentage is 90%. And so here, the sensitivity for this particular test is 90%. We're catching 90% of people that have cancer when they come through and they take this test. Now, the specificity of the test measures how well the test identifies those patients who do not have the disease. So if we look at, well, how many people out of our 100 did not have the disease? That's 90 people. And out of those 90 people, how often did we tell them, yes, you are healthy? That was 80 of them. And so if we take 80 divided by 90, we get 0.8 repeating, which gives us approximately 89%. So what the specificity here is telling us is that 89% of healthy people, when they are given this test, are going to test as healthy. So we note here that there were 10 healthy people who would have to go undergo further testing because they tested positive for cancer when they didn't actually have it. And so they're going to undergo some further testing. In that further testing, hopefully they're going to catch these people don't have cancer and let them know, no, you are okay, you are healthy. Now, on the opposite end, there's also one person with cancer who's not going to receive the necessary medical care because only 90% of the people are being caught. And so since there were 10 people with cancer, there was one person who we told, you're in the clear, you're cancer-free, when actually they did have cancer. For a particular disease, there usually exists more than one medical test. And medical professionals use the sensitivity and specificity to help them choose the best medical test to give their patients. By knowing these numbers, researchers can develop better medical tests. And as a future healthcare provider, you can interpret how good a test is. Well, let's take a look at this situation a little further. What if you are the patient? So what if you are the patient and you receive a positive test result? We want to know how much of a chance do you have that you are not sick? And so to answer questions like this, we're going to use a slightly different approach. We can find experimental probabilities using the numbers from the chart we just made. In the previous example, there were a total of 19 people who tested positive for cancer. However, only 9 of those people had cancer. So for this particular test, the probability that a person has cancer based on his or her positive test result, well, how would we go about finding that? We would take the total number of positive results, that's 19, and out of those 19 positive results, 9 of them actually had cancer. And so if we divide 9 by 19, we get 0.47, tells us that for this particular test, if we got back a positive cancer result, that it's actually only a 47% probability that we indeed do have cancer. So we wanted to know, well, if we tested positive for cancer, what's the chance we're cancer-free? Well, if there's a 47% chance that we do have cancer, we would take 100 minus 47. So in every other scenario, we do not have cancer. So that corresponds to a 53% chance that you do not have cancer, even though you tested positive. And so that was those 10 people who they were cancer-free, but the test said that they had cancer. Well, on the other hand, how well can we depend on a negative test result from this test? If we receive a negative test result, what is the probability that it's wrong and that we actually do have cancer? Well, here there were a total of 81 negative test results. So we'll put that number on the bottom. Out of our 81 negative results, we wanted to know what is the probability that the person has cancer. Well, only one of those 81 negative results was wrong. 80 were accurate, one was wrong. And so if we take 1 divided by 81, we get 0.01 or 1%. And so what this is telling us is even if we test negative, where they tell us we don't have cancer, for this particular test, there was a 1% chance that we actually did have cancer. And so as we are doing this, you want to make sure you're paying close attention to which numbers are being placed in the numerator, which numbers are being placed in the denominator. You should be all ready now to complete the rest of the sensitivity and specificity activity, guys. You're going to take a look at problem 1, as well as problem 2 and 3 here to complete this activity.